Hello and welcome to the AI Research Roundup. I am Alex and today is May 9th, 2025. We are looking at a research paper from Hugging Face's trending list, published just 6 days ago on May 3rd, titled A Survey on Inference Engines for Large Language Models, Perspectives on Optimization and Efficiency. This paper dives into how we can run large language models, or LLMs, more efficiently. It reviews 25 tools, called inference engines, specialized systems making these AI models less costly for complex tasks, like chain-of-thought reasoning, where models think step by step by using various optimizations. Alright, so to better position their work, the authors provide this table comparing their survey to others. It lays out what previous studies covered, topics like model compression, which is about making large language models smaller, and architecture design. Importantly, it also shows the number of inference engines each study actually looked at. Many of these earlier surveys, as you can see, reviewed very few or no inference engines, really highlighting the need for the comprehensive analysis of 25 different engines that we are discussing today. Okay, so to guide us through this complex landscape, this figure presents a taxonomy, basically a structured classification of large language model inference engines and their many optimization techniques. It shows how different engines are categorized, for example, by whether they run on a single computer or multiple computers working together. Then, it details key optimization strategies like batching. Batching is a technique where multiple user inputs are grouped and processed together, rather than one by one, making the whole thing more efficient. And then there's parallelism. This is where complex computational tasks are divided into smaller pieces that can be handled simultaneously by different parts of the hardware, speeding everything up. Okay, building on that discussion of optimizations, this figure here provides an overview of a common large language model structure, known as a quote-only transformer architecture. It illustrates the journey of input tokens, essentially the text fed into the model, which are first converted into numerical input embeddings. Then, positional encoding adds information about word order. This data flows through transformer blocks, which critically feature multi-head attention mechanisms. These allow the model to weigh the importance of different words, and feed-forward networks, another processing step, ultimately producing output probabilities via a softmax layer. Understanding this internal flow is key, as inference engines target these specific components for optimization. So we just talked about how multi-head attention is a critical part of transformer blocks. Well, this figure dives deeper into different types of these attention mechanisms. We see multi-head attention, or MHA, where each query, which represents a part of the input seeking information, has its own set of keys and values, which hold the information to be attended to. Then there is multi-query attention, MQA, and grouped query attention, GQA, which cleverly share keys and values across multiple queries to reduce computation. Finally, multi-head latent attention, MLA, involves a compression step. These variations are important because optimizing attention is a major focus for inference engines. So we have seen how crucial optimizing components like the attention mechanism is. Stepping back, the key takeaway is that a vast array of techniques, like batching, parallelism, and even speculative decoding, where a smaller model drafts text for the main large language model to quickly check, exists to make large language model inference efficient. This survey really underscores that selecting the right inference engine for specific needs is critical for managing costs. The field also looks to future support for multimodal large language models, which handle images and audio too. That is all for this AI Research Roundup. Thanks for joining.